Hi, morning. How are you? Happy Valentine's. The time that I'm videoing this is the 14th of February. Yes, I would be out this afternoon, but like before I go out, I like to just give you guys a little bit of math and torture you on the day. So what we have done so far, we've done quite a lot of summary statistics. We talk about standard deviations, and we also talk about those means and box plot and all this. And and today, I just want to remind you that you need to do your workbook. I just received an email from school sometimes saying that you don't have enough work to do. Surprising to hear that because I do have quite a bit of work. So just to remind you that you do have your workbook, and the workbook look like this. And if you don't have it, let me know. Then I will send you a copy. The office will have a hard copy, or so I'll send them a soft copy as well. So make sure that you've got this workbook. And workbook has lots of different parts. Part A, you've got 15 multiple choices. Then you are basically up to your majority of the concept we've been looking at in the last 2 weeks, so it should be fine. And part B is descriptions of univariate data, some negative and positively skewer, symmetrical. So you are able to do the part B now because we've done the normal distributions. I'll come back for normal distributions and box plot later on. Then you have all the multiple choice and short answer questions for part B. Then you move on into part C. It's about more normal distributions and related to the score, or standard score or set score. So that we keep going on and on and on and on and on. Page 12 and then page 13, and then you've reached to the definitions. So then part D. So part D is the one that I'm going to look at next class, and it will be the last video of before I come back. So you'll be fine. And this one would be video 5, yes, next 6, and 7 is the last one, which is the much shorter one. I'll giving you the ideas about the first sec that you're going to do. Then I will be back. Then I can see you in person and see how well the course been doing, and I'm happy to catch up with you. Any work that you need more help with. So after this is the last part of it, and keep going on and on and on about and part D is a summary exercise. For summary exercise, I don't really expect you to do all of the summary exercise. Just try your best. If you couldn't finish all the summary exercise, it is okay. But up to page 20, I would expect you to finish by then. Please start looking at them, and I won't give you any guide question from now on. Then I'd like you to just go to your workbook and do all the questions. If you say I've done all my workbook and I have nothing to do, congratulations, you don't have to come to school until I come back. Just if you have done it, right? So if not, you still come to school, do your work until you finish. Hopefully it makes sense with you. Today, what I do, I'd like to help you out with some past C questions. And the very first one is on just question 1 in past C. And this is a concept that we discussed last time. It's not easy, so I'd like to go through them again. In your workbook, I do give you a pen, kind of a brief notes about standard deviations. I also give you lots of different notes about that. You can find those in your book as well. So the normal distribution, still remember, is a symmetrical one. So it's a mirror image, left hand side, right hand side. And we draw the graph according to the standard deviations. So you can have 3 parts. is a 68, 95, and 99.7 rules. In this bell curve, you try to set up the first region from -1, so from a mean -1 standard deviation all the way to mean, then on to mean +1 standard deviation. This is 68% out of the whole shape. So if the whole bell shape is 100%, 68% of the area would cover in between -1 standard deviation, -1 standard deviation to +1 standard deviations. Yes, then you will find out if you take one step forward, left hand side, right hand side, then this particular gap would be 2 standard deviations. In between the mean -2 standard deviation all the way to the mean +2 standard deviations, you have 95% of the area for the total bell shapes. Then, as I said, how about like if you move one more, there will be 99.7%. And as I say, you just ignore the 0.3%. They are monster out of the group. We forget about them. So it's 68, 95, 99.7%, right? And if we done that, try to look at question 1. Is the normal distribution related to the z-score? And the z-score or standard score is talking about how many standard deviations is it away from the mean. It could be a negative value or positive value. When it's a negative z-score, it means that it's go below. It's like from 0% to 50%, the group is in the first half of the graph. Then if you have a positive value, that would be the second half of the graph is go above the mean. Now, very quickly, you can tell me question 1a. This one is 45. If you look at the mean equals to 50, this one will have a negative z-score, right? Because go below. That one is smaller than the mean. When it's smaller than the mean, you have a negative values. Then 50, your standard score would be equals to 0. It's right there. Right there. For a z-score, 0 is good because you're right at that point. You're right in the middle. You are the majority. You rule the bell curve. Person C is a bit higher, so that would be a positive score, right? So this is always the first step. You know that. Then 45 and the standard deviation perfect is 5. So you can tell straight away. If you look at the bell shape here, this is 50, this is 45, and this particular region here telling you is from the mean. This is mean minus 1 standard deviation, and this guy is right here at this spot. This spot is 1 standard deviation backward, so therefore it's -1 as a z-score, or -1 standard deviation. A z-score would be -1, and -1 would be the maximum you can get is like -3. You don't really get beyond -3 for a z-score. Is between -3 all the way to +3, and -1 is not that bad. It's just 1 standard deviation away from it. Then plus score right here is 55. When it's a 55, it's right here, and you just move 1 standard deviations across from the mean. Then if that basically equals to +1, and that's that simple. Nothing really fancy. For the z-score is how many standard deviation is it go beyond from it. So now if I asked you, if I go beyond from that, this is easy question. So what if I have D, a person 4? Then it has a pretty good score, about maybe 67.5. What would be the z-score? what would be the set score? What would be the standard score? And E, a person 5, it's not that good, is only get 42 out of it. So 42. So what would be that set values? If I need to look at the graph again, the bell curve, 1 chop, 2 chop, this is 1, this is 2, this is 3, this is 1, this is 2, this is 3. If right in the middle is 50, 1 standard deviation is 45, 2 standard deviation is 40, last one is 35, then the 55, 60, and 65. The first one there, 67.5, basically go beyond the regions. Let's make this up a bit smaller. That's not that good. Let's say change into 62.5, which is brilliant according to these statistics. Because 99.7% of the score is between 35 to 65. None of them, not many of them go below that and above that. So you've got 67.5 is out of the scale, is monster. Forget about that. Now, I'd like to ask, what would be the set score for person 4, X4, 62.5? There's a formula for this. Instead of looking at the graph, you know the 62.5 is somewhere here. And then you can tell it's 1 standard deviation and 2 standard deviation and a little bit. How can we find this particular little bit? The formula would be your numbers, take away the mean, divided by the standard deviations. So what do is we are asking ourselves how many deviation is away from it. So for the first one is -1, because 45 take away 50 divided by 5 is -5 over 5, give you -1. So we understand what's going on, but try to apply this into formula. Sometimes, this is formula, I don't know how to do it. But it's basically, you know it. If you're able to do A, D would be exactly the same. You just apply exactly the same process. It's 2 and a little bit. How do you know exactly? It would be 62.5, take away 50, divided by 5, which is 12.5 divided by 5. I can't do it in my mind, then use calculator. 12.5 divided by 12.5 divided by 5 equals to 2.5. But it's positive. As I say, positive 3 is the maximum you can get. Positive 2.5, you are close to monster. This is extremely good. It's like basically the top. Like if you talk about this, maybe the top of the class or just the second one. Right? Person 5. 42. When you try to look at 42, you go 1 there, and before you reach 40, it's right here. It's 1 and a little bit, right? But it's go beyond, go negative. So what do you do according to that? The same thing. X5 is 42, take away mean 50, divided by standard deviation. 42, take away that is -8 over 5. 8 over 5 is a 1 and a little bit. So let's do it calculator. Divide by, no, I can't remember. 8 divided by 5. 8 divided by 5. I've got 1.6, but it's going to be a negative. So therefore, -1.6 would be the set score. Happy about that? So we can start from a simple concept, then develop the formula. Then apply to the formula, we're able to calculate the set score, no matter which way. It's just how many, or whether you move forward or move backward. How many standard deviation? 1 standard deviation, 1 step. So you move by 1 step and then a little bit. Right? The next question is the question 5 on part B. What proportions as IQ score. Do I have? I think question 5 missing. Missing information. So try to go back to look for them. Question 5. I can't do that because the questions don't have enough information at all. It seems like I'm missing the information in there. It's okay. Let's try to make this one up. I have to change that here. So try to use this information when you do your workbook, because like the normal distribution there's two things for normal distribution. One is the mean. I didn't give you the mean, and the other is the standard deviation. And both of the information are missing. I don't know where they are. So let's say I make this up myself. The IQ thingy there, most of the time is 100. So all of them is 100. It's the basic. It's kind of like, yeah, the average. The average IQ is 100. Then I think the standard deviations is about 10. Right, so about 10. So let's make this one up, and I'm have the idea. I think I remember that this is what happens. So if you have the mean as 100, IQ equals to 100, and the standard deviation is 10, then we can find out. We need to like calculate the proportion of people. So proportion of people is different from set score. For set score is easy. So for 115, the set score is equals to 100. 115 take away 100 divided by 10, which is 15 divided by 10 is 1.5 positive straight away. So I know that if the mean of the IQ is 100, and then if anyone score 115, the set score would be 1.5. However, what I'm trying to do here is doing the proportions instead of a set score. Proportion, we always need to go back to a bell curve. For proportion there, so here would be our mean, which is 100. Then, if you say one step here is 110 because one standard deviations, and then 120 is here. Is 2 standard deviations. 1.5 is right that point. And look at that. The question asking you, the regions, not the region that from this point you have two sides, either below than 115 or bigger than 115. Then, according to that, we want to find out people that is above, which means that the whole area here is what we want. You say, I don't understand. How can I find out the percentage of it? The percentage of it is not that difficult to find out because we know the rules. The rules of that is 68, 95, and 99.7%. Right? And if we look into the notes, if you go and find out the notes that I give you, it does give you the ideas how many of them for each region. So most of the time you can basically find out each region of it. So how many regions we have? 1, 2, 3, 4, 5. So there's 1, 2, 3, 4. So 1 standard deviation, 2 standard deviation. What? Sorry, not this point here. This still belongs to the same regions. 1 region, 2, 3, 4, 5, 6 regions. So 6 regions in there. And if you just look at 3 and 4 regions, would be equals to 68%. If you look at 2, 3, 4, 5, from between 2 and 3, and then 4 and then 5, would contribute 95%. If we just add 1 all the way to 6, 1 all the way to number 6, that would be 99.7%. So what happened? If 3 and 4 is 68% is a symmetrical, that means 3 and 4 will be half of them. Half of the 68% would be 34 and 34. Yes? So let's try to write this down, because we know that this is 34%, this is 34%. Add together is 68. Right? So hopefully you remember the shape that I gave you right here. We've got 3 rules. And the rules right there is couldn't find it. It's 68. You can find it out there. 68, 95, 95, 99.7%. Then if you look at 95%, 3 and 4 make 68 already. And 2 and 5 are symmetrical. So 95, that means 95%, take away 34, take away 34. 99, take away, give me a second. So if we've got 95%, take away 68, I've only got 27% left. And 27% is split into 2. One goes to 2, one goes to the 5. So divided by 2 equals to 13.5%. So that means if I try to highlight this region, number 2 there would be 13.5%. And number 5, the whole thing there, the number 5 there is another 13.5%. And how about 1 and 6? 1 and 6 would be talking about from 1, 2, 3, 4, 2, 3, 4, 5, basically 99.7, take away 99.7, take away 95. And 1 and 6 is going to split 4.7 between each other. So 4.6 contribute 1 and 6. Divide this by 2, 2.35. So each one of them here would be 2.35%. And this one is 2.35%. So from 1 onward, from 1 here, that is 2.35%. And the 6 is 2.35%. Very tiny bit. 100 people, there's only 2.35% there. Right? And then the crazy bit, the monster range. The monster range is 100 take away 99.7, 100 take away 99.7. Sorry. .3% for both sides. So each side would be 0.15. The monster is 0.15 from this region, go beyond 3, -3, and beyond plus 3 standard deviation is 0.15%. So there is the monster, 0.15%, and monster, 0.15%. So if we've got this range, I'm sure that we've got this particular diagram highlighting all the percentage. in the book. So you don't need to remember any number here at all, but you just try to draw this one yourself on your notebook. Then you always refer, okay, this is number 3 is 34, number 4, number 5, number 6. Now, how can I use this percentage, apply, and answer these questions? Then 155. So I know that this region has to be the monster one. Let's try to use red pen. So I have to include it 0.15, and I have to plus the second one 2.35, and I have to add 13.5. If I add 13.5, would be exactly right here. All of them. Anything from this point all the way. But this is only like halfway through. This is like halfway. From this one here, and we need to work out what would be the percentage here, and then try to find this one. So can you see this shape? If I change this part and move it there, that would be the whole square. And this whole square equals to 13.5%. And I would say that this one, this yellow bit, would be half of the shape, take away this top part. So 13.5 divided by 2, then the things that we worry about is this triangle. If we know about this triangle, then we would be able to find out exactly what would be the percentage of it. But at this point, I think we just try to guess a little bit instead of doing the whole extreme calculations. So if I need to kind of like estimate, I need to add the very last one, 0.15, plus 2.35, the monster range and the expert range. Then the range number 5, I take half of it, 13.5 divided by 2. If I need to estimate, it's more like this one has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 of this triangle, and I just need to take one off. So basically, I need to take away 13.5 divided by 12. Because like if I take half, that would be the whole area like this as a total region. But for the anything above, this triangle is the extra. We cannot count this triangle. So this particular triangle, we need to find a way to take away it. So to do the estimation according to the graph is about 1/12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 1/12, so I divide this by 12. I have the first one, the second one, and the third one. All add together. .15 plus 2.35 plus, put a bracket here, 13.5 divided by 2 minus 13.5 divided by 12. Close it. about 5.6%. So my estimation would be 8.1%. And that's the answer. 8.1%. So how about 130 score? 130 is extremely easy because 130 and about, this is 110, 120. And 130 is right there. And all we need to do is to tell people about this monster range. Is 0.15%. But make sure that look at the questions. Is anything below? So if one out of 100%, there's only 0.15% get 130 and above, take away it. So therefore, 90, 100, take away 0.15, which is 99.85. 99.85% of the people will be below 130. Okay? So the last one is 85 and 115, which is very ridiculous. So 10, 90, 80, yes? 85 is from this region all the way to 115. So 115, the one that we just found out before, this region. Without doing the first one is extremely difficult, but because we've done the first one, with about 8.1% there, or above. That is, yep. We know that this highlighted region there is 8.1%. This highlighted region is not 8.1. This highlighted region is 5 point something. According to that, is 13. Just do again. 13.5 divided by 2 minus 13.5 divided by 12. That region is about 5.6%. 5.6. Remember this. So if we're looking at this region here, is about 5.6%, and then you plus 2 and 55 plus 0.15, we've got this all together equals to 8.1%. Basically as the graph is symmetrical with each other, so this one is 8.5 beyond 150. The one that smaller than 85 would be 8.1% as well. So if you chop the region on the left and chop the region on the right, you will able to find the 85 would be 85 to 115 can be calculated by doing 100%. Take away one side is 8.1%, the other side is another 8.1%, equals to 100. Take away 8.1 and take away another 8.1. Do it again. So 83.8. And then minus 8.1. 83.8%. That is the answer. Right? It looks like, yeah, I can see your face will be exploding, a bit confusing according to this graph. Yeah, that is not an easy question at all. But like you will require to know about this particular shape. And in the exam, it's not that difficult, not as difficult as this. They're normally asking you for the perfect standard deviations, not somewhere in the middle. If you find that somewhere in the middle is much harder because the curve is going up and it's not a rectangle, so you can't really divide it by 2 for the answer. you notice slightly less than 2. Yeah, so hopefully you find it all right. And you need to do now your workbook. So make sure you've done that all the way all the way down to the summary exercise. So if you can do the summary exercise, go ahead. But this is what you need to do. So before I come back, thank you for listening, and enjoy your rest. Enjoy my rest of the Valentine's Day, and so do you. Bye.